Alright, so today I'm going to talk about what to do or how to troubleshoot a no internet connection. I want to make sure that this is distinguished from a slow internet connection because the two would be troubleshot very differently. Okay, so I'm going to draw a couple of devices up here. Your setup may vary. We'll kind of discuss the different things that are involved in a typical internet setup, but I'm going to kind of break it out by components. Everything that you need that is required to get you or your computer on the internet. So first thing you have is a modem. Alright, and then I'm just going to write all this up and then we'll kind of do the breakdown. You have a modem, you have a router, you have a switch, and then you have your computer. And there may be some other devices involved here, and I will get into that as we kind of expand in this topic here. So for a lot of people, what you may notice or what you may realize, depending on your service provider, all of these devices right here may be in one unit. Okay. Again, so you have these three devices here, which might be bundling your gateway, depending on whether you have AT&T, Time Warner, Comcast, what have you. Typically they'll sell you a device that'll include all three. Okay, so we got to discuss how this works. Because again, if you don't understand how your internet connection works, if you go to troubleshoot it, you're really taking shots in the dark, and that's not necessary. Let's learn how it works so we know how to fix it. Okay, so first things first. When your signal leaves your house, it leaves from the modem. Okay, now the remote terminal, which is going to be out in the field somewhere, this will be where your service provider technically picks it up. Okay, so that may be upwards of 3,000 feet away. So what your modem does is it modulates this signal into an AC waveform for broadcasting. So one way to look at it like this is your modem broadcasts your internet data out to that remote terminal. So on this waveform, which is AC, it packs on these ones and zeros, your digital data. Okay? So your ones and zeros are modulated into that signal. As a matter of fact, modem is an acronym for modulate and demodulate. Okay? So, your modem's sole purpose is this, is to get that broadcasted signal out to the remote terminal and to receive a broadcast signal, whether it be ADSL or whatever format, depending on what your service is, coming back from the service provider, and its output back into your house is your Ethernet. Okay? So your modem's job is to handle the broadcast out, receive the broadcast in, and pump out an Ethernet signal. Okay, so your digital data, your ones and zeros. So I'm just going to kind of put ETH here for Ethernet. Okay. So what your router then does, your modem hands off to your router, and in my particular setup, I have two devices. I have a modem and a router. However, I think troubleshooting it all in one is easier. However, I found that it's cheaper typically if I buy the router and the modem separately. Okay, so either way, the Ethernet signal comes into the router, and the router's job is to deal with the TCPIP protocol, or your external public TCPIP address, and get it onto your private IP address. Okay, so essentially, while you're out here dealing with TCP/IP, you're on a public internet address. Your router's job is to translate that from your public internet face to your private internet face, so that behind this router you can do whatever you want with your network to expand it. So this is why, even though you only have one IP out here from the internet service provider, once you're behind or on the other side of this router, you can have as many IPs as you need for as many devices as you need. Okay. However, they're all, of course, sharing that one connection. They're all routed through that same connection out. So it goes from your public IP to your private IP. It switches networks. To put it simply, anytime I see router, your router handles switching between networks. There's no other device out there that can switch between networks. If it can do that task, it's called a router. This is different from a switch. Your switch typically handles traffic at the MAC address level, or on the OSI model, level 2, for those who are familiar with that. So basically, once you get to your switch, your switch, to keep it simple, is responsible for distributing that private IP connection. Okay. Now, within your router, you probably have your DHCP server, and your DHCP server is responsible for handing out all the IPs that you might need. As I discussed before, out here you have one IP, but on this side of the router you can have as many as you need. Well, that's what the DHCP is responsible for, Dynamic Host Control Protocol. It can give out IPs for any device that you need on here. Okay, the switch doesn't do that. The router, or whatever is serving as your DHCP server, does. Again, if it's all in one, it kind of just blurs together. But this is kind of the breakdown of one person's gateway. And I'll go ahead and label that up top here. Now on your switch, you might notice on the back of your gateway, now this is actually a Ethernet switch by itself, but you might notice on your gateway that you have a variety of different ports that are coming off of it that can be wired. Of course, these can be for different computers, but the responsibility of the switch is to give you access to your Ethernet network. So assuming that you have a DHCP server in place right here, once you hand off to your switch, anytime you plug a computer into one of these, it's going to automatically receive an IP address from this DHCP server. So basically it kind of turns it into a plug and play. You plug it in, it works. You plug it in, it works. Plug it in, it works. But nowadays everything's going Wi-Fi. Yes, wired connections are more reliable, I believe they're a little bit faster, but Wi-Fi seems to be the most convenient way to go. And with the 802.11g protocols getting better, you never skip a beat, Wi-Fi or wireless, it seems. So from your switch, you have a connection, let's say a wired connection to a CPU. If your network switch is close to your main computer, go ahead and wire it. It's going to be a more reliable connection. Okay. Now, inside of this gateway, we're going to go ahead and draw in our Wi-Fi, and I'll put it in red. We have a signal that's broadcast, and your gateway router typically handles that. Broadcasts out for your local devices to connect. Okay. Now, keep in mind that your gateway router at this point, again, like I said, is also kind of acting like a switch, because whatever connects to this device, this gateway, is also going to receive an IP from the DHCP server. However, instead of it being a wired connection, it's negotiating it wirelessly to connect. So the way that it keeps track of which computer is which is called the computer's MAC address. And every computer or device has a MAC address. If you you're not going to be able to see it here, but if you look at your label, sometimes it's on the network card, sometimes it's on the laptop or device itself, but it has a MAC address. So your iPhone, your Android, anything that you connect wirelessly has a media access control address, a MAC address. And what this MAC address is responsible for is it's like its name. At this level, when we're handing out IPs, we need to know what to attach an IP to. So once you bind an IP address to a MAC address, then you have an address. Or once you bind an IP address to a MAC address, then you know where to send data. So let's say we send a computer this first CPU 1, an IP address of 192.168.2.1, and it will bind within the switch. This is the responsibility of the switch. It'll bind that IP address to a MAC address like A1, B2, CC, 7851. MAC address will look something like that. That might not be the full length of it, or it might be too long, but your media access control is basically going to be hex, numbers 0 to 9, letters A to F. Okay, so once that's bound to an IP address, now the switch knows how to manage the data. Same happens wirelessly. To find the MAC address on a Android or an iPhone, you actually have to look into the settings and the information, and then you can pull that there. Okay, so that's how your gateway gives out the IP address, and now once your CPU wired or wireless gets that IP, you can send data through the switch. Switch manages it to the router. Router takes it from private to public, puts it on the modem. The modem modulates it and sends it out to the remote terminal. So now we're going to switch to part 2.